Okay, example 2, same type of problem, same issues going on. Notice the order of your complex number on the bottom is in the wrong order. It's not that A plus BI order that I really like. Okay, even though it's not, I can still make a complex conjugate. So again, if I take the same two objects and I change the sign, just know that our final answer, we want to put that good A plus BI order in our final answer because we're going to be sticklers for a specific technique or thing. For me, this is already 4 minus 2i here. If I make this 3 plus 2i, that'll create that basic structure we're used to, which is real number, I to the first, I to the first, I to the second. If you did it the other way around, you're going to get the same answer, just the order of the objects will be in different places. So if you like things to be in the same place every time, you can do that. These are equivalent, so it's legal to do that. If you want to do 2i plus 3 also, it still works. Take your pick. I'm going to go with this because I already wrote it down. Again, if I FOIL the top, 4 times 3 makes 12 this time instead of 3. Actually multiply them this time. 4 times 3 is 12. And then our outside product, positive 4 and positive 2i make positive 8i. So again, both of those multiplications, 2 positives make a positive, 2 positives make a positive. The inside multiplication, negative times positive makes a negative, 2i times 3 is 6i. And the last times the last, a negative times a positive makes a negative, 2 times 2 is 4, I times I makes I squared. And just like before, real number, I to the first, I squared. All I squared does is change the sign and make a real number. I squared equals -1, multiplication by -1 changes the sign. On the bottom, rather than doing FOIL this time, I'm just going to do the F and the L part of FOIL. So first times first, positive times positive makes positive, 2 times 2 is 4, I to the second power. Last times last, -3 times positive 3 makes -9. Okay, opposite signs get a negative. Again, the outside product 6i, the inside product -6i cancel. That's not coincidental, that happens every time. The whole multiplication of a conjugate is going to create that scenario every time. So first, last, get you the product you're looking for. And once again, we have an I squared in our object. It's positive 4i squared, which really means -4. So again, the I squared makes -1. It just changes the sign, makes a real number. So our end result is 12 plus 4, which is 16. 8 minus 6 makes plus 2i. And all that goes over -4 minus 9, which is -13. So my final solution then is, again, I want to break it into a real answer and an imaginary answer. So I'm going to write 16 over 13, and that'll be negative because the signs are opposite. And 2i over 13, that's not supposed to be that good. Didn't reach quite high enough. Blue, okay. 2i over 13, that's also negative. And that's our answer. Okay. Now, one thing I wanted to mention before I finish this problem up is this imaginary answer that we're writing. -2i over 13, -2/13 I, like that. Those are both good. -2 over 13i is bad. Okay, make sure that I doesn't end up in the denominator. Okay, so if it's off to the right, so it's still officially times a whole number structure, that's multiplication, it puts in the numerator. If you actually write it in the numerator, that's fine. Make sure you don't draw it so it looks like it's in the denominator. That's just, basically you're back to the same point we were in the beginning with, right? We still have an I in the denominator. That's bad. So make sure that you don't get that look in your final answer. Make sure the I personally, I usually write it like that. We're just right up in on the top, right where it's supposed to be. But you know, as long as it doesn't look like it's in the denominator, I'm not too nitpicky about it. I mean, if you got this answer and put the I too low, I might make a note, make sure the I looks like it's on the top. I'm not going to count it wrong at this point. But if you continually do it again and again and again, at some point I'll start deducting points for it.